What's going on, everybody? It's Kistner here. I hope you're having a great day. Um, this is your lesson 1.2 video notes, and I am not a fan of the examples or the book's way of teaching this section in your student companion or whatever. So we're not going to use a student companion today. We're going to use these guided notes that I handed out to my B3 class and my A1 class. If you are watching this video and have not downloaded and printed those guided notes, go back to where you click the link on the Google Classroom for this video, and attached to that is a PDF of those guided notes. I would print those off. It will save you a ton of writing because it has everything that I'm going to draw on already printed off for you. So make sure you've done that. With that being said, guys, let's get started. We need to know what parent functions and transformations are. So a parent function is a general equation of a certain type. Okay. So for example, let's look at just the most basic parent function. Okay. The general equation, a parent function of a constant function. Fill in the blanks with me here. I will check these on next class. Is f of x equals a, where a is any number. That's like f of x equals 2, f of x equals 3, f of x equals 4. You name it, that's what it is. Now, last class, we talked about what domain and range was. And, sorry, the domain of that is all real numbers, and the range is just whatever number you said it was. So if it's 2, it would look like this. F of x equals 2 is that. That's the general function. So if we labeled what this was, we would say this is f of x equals 2. Now, that's a simple one. We won't deal with those very often, but don't forget that y equals 2 is a horizontal line. The other ones that we'll probably talk about are things called identity functions. And that's f of x equals x. That's things where you get points like 1, 1, 2, 2, 3, 3, 4, 4. It's the line x equals y, or y equals x. It passes through all points with coordinates a, a. So you plug in 1 for a, y is also a. So y is also 1. X is 2, y is also 2. X is 3, y is also 3, so forth. It's the parent function. This is very, very important. It is the parent function for most linear functions. You can see this could be y equals mx plus b. This could very well have been written y equals 1x plus 0. Y equals mx plus b. Because what it looks like is, let me get the right color going again, this. Goes through 1, 1 all the way up to 0. It goes on forever in that way. So it's y equals x, or f of x equals x. Remember, y and f of x are the same thing. The domain is all real numbers because it goes on forever left and right. And the range is all real numbers because it goes on up and down forever. It'll go forever and ever that way, and forever and ever down. It's a line. That's going to be true for all lines. That's just a little thing to remember. Domain and range for all lines are all real numbers. Now, here's more into what we've been studying in class recently. The f of x equals the absolute value of x is the parent function of the absolute value function. There's no like fancy way to say it. It sounds redundant. Absolute. I'm going to evaluate abs value function. Okay. And what that looks like, if I can get the right line stuff going on here, is a V going off on the 1, 1 line, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, but it also goes off negative 1, 1, negative 2, 2, negative 3, 3. It's a V. Okay? The domain is still all real numbers, but the range is real numbers greater than 0. We did this in class with one of your try it examples from your student companion. It was I think it was try it 2 A, like the back of the first page or something. But this is the absolute value function. This is f of x equals the absolute value of x. Okay? 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3. Now, this I need to fix. This should not be like that. This should look like, hold on a second. Let me get rid of that, because that's not what it's going to be. It doesn't equal x2. It equals x squared. Okay, x squared. Now, the parent function of, we're going to call these quadratic functions. Is f of x equals x squared. The domain is all real numbers, and the range is all real numbers greater than 0. That's just for x squared. It looks like a parabola, where you go 1, 1, negative 1, 1. You go out 2, 2 squared is 4, so we get up here at 4, and negative 4. And the nice thing about this is it's symmetrical, 3, 9, negative 3, 9. So if you do it to one side, you automatically have the same shape on the other side. And it's tough to draw with this little pen I'm using, but it looks something, and I always miss that one. Looks something like this. Okay, that's the general function. Now, we're going to mess with all these parent functions. We call them parent functions because they're the originals. And then all of these are going to have little children or little transformations of their own. All right. Now, let's go ahead and turn the page and talk about the different types of translations we're going to see. The first thing is a translation. A translation simply moves a figure up, down, left, I feel like I'm saying the Konami code, or right. Extra points to those who know what I just said. It moves a figure up, down, left, or right. So an example would be something like if f of x equaled absolute value of x, the transformation might be, don't use f, use g of x is the absolute value of x plus 2. This is the translation. Okay, this is the translation right here. And what it does is it takes that old absolute value function like this, whoops, I lost it already. So go ahead and draw an absolute value function. Okay, and it's going to move it up 2. It moves it up 2. So what it looks like is if I just take this thing and I'm going to copy and paste. Oops. Sorry for the headphone users there. If I can do this right, copy, paste. It moves it up 2 units, and every point gets moved up 2 units. So the blue one is the translation. The blue one is the translation. Okay? If I had said -2, it'd move it down. And we're going to learn how to move it up, down, left, and right with using different coefficients and numbers and things like that on the last page of these notes. A reflection is when you flip the figure over a line of reflection. So we flip the graph over a line of reflection. Okay? And there are a few ways to do this. One way is to multiply the parent by -1. This flips the graph over the x-axis. If you multiply the parent function by -1, it flips the graph over the x-axis. Okay, that will look like this if we had it. It's just f of x becomes negative times -1 f of x. So if we had a parabola, let me go ahead and draw my parabola here: 1, 1, 0, 0, and 2, 4. I'll just do this right here. Okay, if I draw that in real fast, like, it doesn't have to be perfect on these because we're just using them as an example. If I flip that thing, it would come in and be sitting like that. And it would be, let's change the color so we know it's the different one. The blue one is the transformation, sorry. It's a reflection. We simply just flipped it over the x-axis. Okay? Now, if we multiply only the variable, so now the other way to do it would be to multiply only the variable by -1. You flip over the y-axis. Now this wasn't a very good example of that, because if I flip this thing over the y-axis, it just looks like it's the same thing because it would just fold on top of itself. But we'll see that coming up in a few examples. Remember, if you multiply the entire function by -1, it flips over the x. If you multiply just the x, just the variable, it flips over the y. And the last one is a dilation. And this is the one that confuses a lot of people. Okay? Confuses a lot of people. So pay attention to this one, and the last page is going to be very, very useful. It's kind of like that chart I handed out last class. But what a dilation does, if you think about going to the eye doctor and you get your pupils dilated, they kind of change the size of it. A dilation shrinks or stretches. Sometimes you hear them as compressions. Shrinks would be compressions. Shrinks or stretches, enlarges a figure proportionally. So you stay in proportion to everything. Everybody, I hope, knows what proportionally means. Shrinks or stretches a figure proportionally. So if we have f of x equals, let's just use the line, equals x. So if I come through here and I draw f of x equals x, we'll make it red again. It goes, remember, it goes 1, 1, 2, 2, 3, 3, and -1, -1, -2, -2. It hits all of those points on that perfect diagonal. That's the line y equals x, or f of x equals x. Okay? If we, I don't know, put f of x, let's use a different one. I always want to use f. Let's use g of x equals 4x. I have multiplied the variable by 4. This is what a dilation looks like. And you should know that's a line. And it goes, well, it has the point would be 1, 4. So here, if I start my line here, it'll go through 1, 4, and on up. So what this did, and 1, -4. Okay. What this really did is it took the points that should be at 1, 1, and it stretched it vertically to 4. It took the point that should be at 2, 2, and it stretched it vertically to 8 if I had drawn the line right. Okay. It took the point that should be at 3 and stretched it vertically to 12 because I'm multiplying it by 4. I'm multiplying the entire function by 4. Now, I've done a lot of different transformations, and I've talked about what each type are. So let's fill in the chart. Turn the page. Here's the chart. So if this is the translation, you can use x plus h. That's going to be something grouped with the x. or x minus h. So if they're grouped with the x, you got to think the x-axis is the horizontal axis. So these are going to be horizontal shifts. Horizontal shifts. So if we're going to move horizontally, what's going to happen is the h, we're going to move that many. Oop, jumped all over the place. Sorry, guys. This is being really annoying. F of x plus h is going to move to the left h units. So if h is 5, plus h is going to move it to the left h units, and minus h is going to move it to the right h units. Now that's strange, because normally on the x-axis, the right is positive and the left is negative. And if you notice, plus moves it to the left, moves it negatively, and minus moves it to the right. Now there's a teacher who hasn't taught here for 2 years, and she had a way of memorizing this. Anytime you're dealing with a horizontal shift to the left or right, the horizontal stretches, shrinks, or whatever, it's backwards what you think. It's crazy. It's not what it should be. Move to the left, you're adding. Move to the right, you're subtracting. That's backwards. That's counterintuitive. So this elderly old lady would always tell her class, that hoe is crazy. Now, I'm not going to say that very often, but she would say, that hoe is crazy, because the horizontal shift, the HO, horizontal shift, is backwards what you think, and I never forgot that. So that's the way I memorize it. Now, plus K minus K over here, we just switched up the letters for the heck of it, is going to be your vertical shifts. You move up K units, or you move down K units. Those are normal. Those are normal, so make sure you write these down. You can pause the video anytime and copy these down. A reflection, a negative f of x, we've already talked about that, is going to shift over the x-axis. Sorry, reflect over the x-axis. It's going to pick it up, flip it over the x-axis. It's going to go, if it's already up in the negatives, it's going to go, or positives, it's going to go down in the negatives. It's a vertical flip, but because it's over the x-axis, it's like this. If you put the negative with the x, with the variable, it flips over the y-axis. Okay? And finally, our dilations. Our dilations. This should have multiplication in it. It's going to do something weird. Hold on. These dots should be times. Not going to let me do it. So this should have, don't worry about the dots above it. It should be a times f of x, like that. Okay? Let me get rid of those. I think yours actually has it right. Mom was just kind of throwing me off there. A times f of x, if a is bigger than 1, if the absolute value of a is bigger than 1, it gives you, do I not have it here? Yeah, there it is. It stretches the graph vertically. If a is times f of x, is going to stretch the graph vertically. If a is outside, every point gets stretched higher or lower. If a is a decimal, that's all this means. If it's between 0 and 1, that means it's a decimal. You compress the graph vertically. You shrink it. Now, if you put something in with x's, remember that hoe's crazy, so it's going to be backwards. This should stretch it. It's going to shrink it, if I can find where I put it. It's going to compress it horizontally, and last, it's going to stretch the graph horizontally. Now, we're going to practice this in class next time. I'm sorry the video was a little bit longer than normal. If you have any questions, please let me know. If you know of any friends that can't get on to watch this video, please email me so we're not worried about them. Other than that, I hope you guys have a great day, and this is Kistner out.